All right, so the first reveal is IAA socks. Look at that, I'm a professional. All right, so we have 15 minutes. I'm going to try and tell you everything you need to know about what we're doing with AWS around how we do automotive software development in the cloud. So first of all, I'm going to give you a little bit of update on ARM in automotive. For those of you who don't know us, we're going to talk a little bit about software-defined vehicle. Then we're going to talk a little bit about an initiative called SOFI. And then we're going to talk about the technology, which is allowing us to prototype software in an AWS cloud instance. So, a little bit about ARM. We are an IP company. To date, we've shipped over 250 billion chips with our technology in. And as you can see, in last fiscal year, we shipped 30 billion alone. So the actual graph, ARM's been around for, I think, 32 years. And so the graph of how many chips we've shipped basically did that. So we're kind of ubiquitous in the world. 70% of the world's population touches ARM-based stuff. Now, what about automotive? So automotive, we've actually been in the automotive industry for 25 years. We've built up a lot of ARM-based products, especially around the IVA, IVI digital cockpit, or in a lot of the ADAS and front camera vision systems as well. And then basically all around the vehicle, different ECUs, different MCUs. And what we have done in our automotive group, which I'm a part of, is we've been focusing, taking ARM technology and making it automotive specific. And by that, we've been adding functional safety features into our CPUs, our graphics processors, and our image signal processors. As well as that, we have a very well-rounded, robust automotive ecosystem for software. Okay, and we'll talk a little bit about that in a minute. So let's talk about software-defined vehicle, because that's a bit of the buzz these days. It's underway, okay? It's not complete, but it's underway. Interesting, a couple of quotes here. I thought the Gartner one's fascinating, that 50% of the top 10 automakers will offer new features through software updates. Now, a lot of those are in the IVI system right now, but it's the starting point for having the type of over-the-air updating that's going to be required for our software-defined functions. The other interesting thing is, do we want it as consumers? So this was another survey that actually went out to people that buy cars and drive cars, and almost 50% of the people said they'd pay up to $20 a month. So that's $240, if I'm correct, for additional services after buying the car. Interesting. What's interesting is 14% said they'd pay up to $50. So obviously people that buy cars have got a lot of money and quite happy to spend it, which hopefully is a good rationale for us doing the software-defined functions that allow us to do updates and upgrades. So, as we look at the technology required and what's needed for the software-defined vehicle, the first thing is, it's the ability to deliver these advanced features. It's the ability to do updates, upgrades, bringing new innovation, new features into the vehicle after the vehicle has left the forecourt. As well as that, we need security, but we need scalability. The idea that your car will be the same in 5 years' time as it is today is going to change with the software-defined vehicle. So, looking at this from a kind of technology lens, what do we need to actually achieve this? What do we need to make the SDV real? So firstly, there has to be some element of standards. We can't, each of the automotive OEMs just can't do it all on their own anymore. There need to be standards out there that people can use and reuse and also can collaborate. What we're going to really talk about today is some of the new software methodologies. You can't build the car software the way it's traditionally been done with a software-defined vehicle. You need it to be more agile. We spoke about that in the previous slide. For that purpose, we need to also be able to simulate our vehicle, because you're going to start developing the software a lot earlier than when you actually have the vehicle or even the hardware that runs in the vehicle. And then lastly, we need to all come together. This, however many hundreds of millions of lines of code that's going to go into our cars, needs a group of people to come together. The industry needs to collaborate. So, one way that we can actually essentially make the whole process of software-defined functions in the vehicle more agile is to basically develop stuff in the cloud and then deploy to the vehicle. So it's cloud native, but instead of deploying to a cloud instance, you're ultimately going to deploy to the car. The beautiful thing about AWS is AWS with their Graviton instances basically can have the same instruction set that's going to be in the car in the cloud. We'll talk a little bit more about this in a minute, but this really gives us some very interesting opportunities for software development and software testing actually in the cloud. So what's interesting from an OEM perspective is that having this easy deployability to hardware in the cloud actually is going to help with the component sourcing, because you'll have different, hopefully ARM-based silicon partners that will provide automotive-grade silicon. So you can, if we get this right, you'll be able to migrate your code and move your code from one silicon provider to another. The key thing that this really enables is something called shift left for automotive software development. And I've got a diagram that shows what this looks like. So traditionally, automotive development, you basically start your SoC design, you start your software development, then you build your ECU, then you do your application development, you bring it all together, then you ship the car, and then if you need an update, you go to the dealer. It's the traditional way of doing it. Once we get to the software-defined vehicle, we need to do it differently. So we're going to introduce the cloud. And you can see this cloud line goes all the way along from very early on when the car design starts, to start developing applications, testing them, and then bringing them over to the car. So in parallel, we're actually going to be designing our SoC still, and we're going to be doing our ECU and whatever that looks like. But then we start our system integration here, and we can actually shift left the car deployment over here. Because we've done a lot of the application development here, all these boxes are shrinking. The other kind of key thing is that we can then, once the car has left the dealer, we can continue to update and upgrade those features in the car. As I said earlier, your car of 5 years' time will not be the same as when you first bought it. It should be better. It's like your phones. You don't expect all the applications on your phone to be there when you first buy the phone. You download them and you upgrade them. Oh, we're doing good for time. So, one of the other pillars, if you remember, was industry collaboration. So a couple of years ago, we started this initiative called SOFI, Scalable Open Architecture for the Embedded Edge. It's essentially a software initiative, and it's bringing the industry together. It's this collaboration. It's bringing all of these different types of companies that build things and provide technology to the automotive. And what it's doing is it's basically taking cloud-native software development and bringing it over to automotive. We do it through a special interest group, and you can see down here that the governing members of that special interest group include ourselves, AWS, we've got Bosch and Continental, we've got some software companies, and a couple of OEMs. So it's really, even just the governing body is really kind of bringing together different capabilities, different interests in making the software-defined vehicle a reality. What we're really doing is defining a software architecture. And that software architecture will be realized through a framework that will allow cloud technologies to be combined with automotive functional safety and real-time requirements. We're not deploying to a cloud instance, we're deploying to a car. It has different needs and different requirements. And in order to get going with this, we actually provide an open source reference implementation. So you can start using SOFI right now. You can start developing. If we go back to our shift left, you can start this stuff right now, knowing by the time we get to here, we'll have commercial reference implementations as well. So the whole thing is to get started early in the cloud, have our open source reference implementation so you can start testing it in a vehicle sort of environment, and then migrate over to deployable hardware, deployable software framework. So this is what Sophie looks like. So we basically have some stuff in the cloud, and a couple of the kind of key parts behind making this work is firstly having a way of deploying from the cloud to the edge, or the vehicle in this case. So we have orchestration. We have containers, because that's an easy way of deploying software functions and keeping those software functions up to date. And then essentially you have a virtual environment in the cloud based on Graviton. And then down here, we have essentially a similar environment actually in the vehicle. And you can see this environmental parity is interesting, because up here in the Graviton, we have an ARM Neoverse, and down here we have our ARM Automotive parts. And then the idea is your different applications are containerized, hence in these boxes, and you can run them up here, bring them down using the orchestrator, and then run them the same here. We've been working with AWS to actually show demonstrations where you take that same container from up here and you plonk it in here and it shows exactly the same results. This stuff actually works. So this is the Sophie architecture. If you want to know more about it, come and talk to me after this, or talk to people like Stefano and Luke from AWS as well. So, one of the things that's really important is to start early. So it's nice having the Graviton, and it's nice having the the same architecture in the vehicle. But what's really cool is if you can actually make a virtual representation of your vehicle hardware to run in the cloud. Okay, we can still take advantage of the fact that we're running on the same architecture, the Graviton. But here what we'll start doing is we'll be developing and testing our automotive applications early by having this ARM virtual hardware. This runs natively in the cloud and provides a good representation of what's going to be in the vehicle for software development. So I am not going to go through this picture, but you can look at it. It's basically showing how we get our software that we build up here with our containerized instances using the Electric Cloud Registry, I think it is, for AWS. We run on the ARM virtual hardware up here. We can do our testing, okay? And then when we're ready, we pull those container images and bring them out via the orchestrator and then run basically in our vehicle hardware. And the demonstration is actually a camera which is going to be running here and then showing basically, bounding boxes and stuff like that. So the real automotive applications that we're running in this demo. So if you want to know more about ARM virtual hardware, somewhere around here we have the product manager from ARM for our virtual hardware. Can't see him, but he's probably here somewhere, hiding. But also, you can basically get the AMI for ARM virtual hardware in the marketplace. You can see there's a whole bunch of documentation on it here if you go to arm.com. There's different third-party integrations that we're doing right now. And we can also offer on-prem solutions as well. The nice thing about this is it really is portable as we go through.
Very nice. Big round of applause for Robert Day, everyone.
Thank you.